See, we will solve some problem based on double titrations. 200 ml of a solution of mixture sodium hydroxide and sodium carbonate was first titrated with phenolphthalein and N by 10 HCl. 17.5 ml of HCl was required for the end point. So this HCl titrated with these two mixtures, sodium hydroxide and sodium carbonate. After this, methyl orange was added and 2.5 ml of same HCl was again required for next end point. So find out the mass of the sodium hydroxide and sodium carbonate in the mixture. So we have two cases. One is the first methyl phenolphthalein is used as indicator. So used as indicator. So in this case, what will happen? So here we write here milliequivalent of HCl is equal to milliequivalent of sodium hydroxide plus half of milliequivalent of sodium carbonate, because sodium carbonate will be half neutralized. Okay, so because this is a basic solution, in this solution it will be half neutralized. So this is how much given. So milliequivalent HCl is 17.5 into 1 by 10, so that is nothing but the 1.75. so this is equal to milliequivalent of sodium hydroxide plus again here half of milliequivalent of Na2CO3. Now if you are using methyl orange as indicators, okay, so in this case what will happen? So this will be again after adding the HCl, this will be fully neutralized, so this will be again neutralized by the HCl, so this will convert into full salt. So we can write here half of milliequivalent of sodium carbonate, okay, will equal to milliequivalent of HCl used. Okay, so in this case amount of HCl is different, so that amount is how much? 2.5 into 1 by 10, that is 0.25. okay, so this is our equation first, this is our equation second. So here we know that the milliequivalent of sodium carbonate, so milliequivalent of sodium hydroxide will be how much? So we can use here from 1 and 2 we can write here milliequivalent of sodium hydroxide will be 1.75 minus 0.25, so this will be equal to 1.5. so we can write here weight of sodium hydroxide is nothing but it will be W by 40 multiplied by 1000 equal to 1.5, or we can say weight of sodium hydroxide is 0.06 gram per 200 ml. So this is basically our formula, weight of the sodium hydroxide. So similarly we can find the weight of the sodium carbonate. So weight of the sodium carbonate will be, so milliequivalent of sodium carbonate is 0.25 into 2, that is 0.5. so again weight by 53 into 1000 is equal to 0.5. so weight of sodium carbonate will be how much? So it will be your 0.0265 gram per 200 ml. so this is basically our answer. Now we will see the second question, that is 10 ml of the solution sodium bicarbonate and sodium carbonate requires 2 ml of 0.1 molarity H2SO4 neutralizations. Using phenolphthalein indicators, methyl orange is then added when a further 2.5 ml of 0.2 molarity H2SO4 was required. Calculate the strength of sodium carbonate and sodium bicarbonate in solution. So again, first we have given phenolphthalein as an indicator. So we can write here milliequivalent of H2SO4 is equal to half of milliequivalent of Na2CO3. Why half? Because Na2 on reaction it will convert into Na2CO3 will be in presence of H2SO4, it will convert to first step reaction, that is sodium bicarbonate reaction. This is the half neutralization. So at that time the solution is basic. In this basic solution what will happen? This will give you sodium bicarbonate and phenolphthalein will give color. So here milliequivalent of H2SO4 is 2 into 0.01 into 2, this will nothing but the 0.4. So 0.4 is nothing but the half the milliequivalent of sodium carbonate. Now second, if you use the methyl orange, so if you take the methyl orange after this first endpoint, this is the first endpoint. So for second endpoint, for second we have to use the methyl orange. So here again half of milliequivalent of sodium carbonate, that is the sodium bicarbonate, this will react, and plus milliequivalent of sodium bicarbonate. So this is the original solution, this is the original solution. So it will be equal to milliequivalent of H2SO4, milliequivalent of H2SO4, so which is nothing but the 2.5 into 0.2. okay, so it is 2.5 into 0.2 into 2. So this will be your answers. So it is this is 2 ml into 0.1 molarity, so this will be 0.2. so this will give you here 10. So here our first equation is your 1, this is our first equation is second. So from here we can find what a milliequivalent of this one sodium carbonate. So here milliequivalent of sodium carbonate will be how much? So here half is given this side, so half milliequivalent is given 0.4, so we can multiply milliequivalent of sodium bicarbonate. okay, so this will be equal to 10 minus 0.4, so this will give 0.6. so again weight by weight of sodium bicarbonate NaSCO3 divided by 84 into 1000. okay, so this is nothing but the 0.6. so weight of the sodium bicarbonate will be how much? So 0.0504 gram per 10 ml. okay, so strength will be your strength of sodium bicarbonate. So strength will be your 0.0504 and divide by 10 into 1000, so you will get here 5.04 gram per liter. So this is our strength of the sodium bicarbonate. So now we need to find out the milliequivalent of sodium. So sodium carbonate is how much? So here we will see now milliequivalent of sodium carbonate is how much? So this will be your 0.4 into 2. so already we have seen here from equation 1. if you see from equation 1, this is here, so this is 0.4 into, that is equal to 0.8. so weight will be how much? So weight by 53 into 1000, so this will equal to 0.8, or we can say weight of sodium carbonate will be how much? 0.0424 gram per 10 ml. okay, so strength will be how much? So strength will be of sodium carbonate will be 0.0424 gram into 1000 divided by 10. so here strength will be 4.24 gram per liter. so this is our strength. This is the strength of the sodium carbonate, this is the strength of the sodium bicarbonate. so this is our answer. 30 ml of a certain solution of sodium carbonate and sodium bicarbonate require 12 ml of 0.1 normality H2SO4 using phenolphthalein as the indicator. So in presence of methyl orange, 30 ml of same solution required 40 ml of 0.1 normal H2SO4. Calculate the mass of sodium carbonate per liter in mixture. So here we need to find out sodium carbonate per liter in the mixture. So we need to find first let's take phenolphthalein as an indicator. So what happens? In this case milliequivalent of H2SO4 used is that is equal to how much? That is the half milliequivalent of sodium carbonate, because sodium carbonate is not neutralizing fully. So here milliequivalent of HCl is how much? 12 into 0.1. so this is nothing, it will become 1.2, and this is equal to 1 by 2 milliequivalent of sodium carbonate. So now here we can find the weight also. So weight of sodium carbonate. okay, so this will be given here. So weight of sodium carbonate divided by 53 into 1000. so this is the equivalent. So this is nothing, 1.2 into 2. okay, so this is the weight. So here we can find the weight of sodium carbonate sodium carbonate will be how much? So it will be 0.1272 gram in 30 ml. So this is actually gram in 30 ml. Okay, so we have to find it per ml. So strength is how much? The strength of sodium carbonate will be your 4.24 gram per liter. This is for 30 ml. So for 1000 ml, so we have to we will our this answers. So again, now if you suppose here already question is over, mass of sodium carbonate per liter is this much gram. Suppose we want to find out again mass of sodium bicarbonate is not given here. So for this one we have to take methyl orange as the indicators. So in this case milli equivalent of Na2CO3 plus milli equivalent of sodium bicarbonate equal to milli equivalent of H2SO4 used. Milli equivalent of H2SO4 used. So this is how much used? So this is nothing but the 40.1, that is 0. Sorry, this will be 4. This is the milli equivalent of used. So here we know that the milli equivalent of sodium carbonate. So milli equivalent of sodium carbonate is 2.4 already given here. So this implies that milli equivalent of sodium bicarbonate will be your 4 minus 2.4, that is nothing but the, it becomes here 1.6. So we can do the same thing, that is the W by 84 multiplied by 1000 equal to 1.6. So from here weight you will get here, sodium bicarbonate will be how much? So you will get 0.1344 gram in 30 ml. So for a strength of sodium bicarbonate will be how much? So this will be, so again 0.1344 into 1000 divided by 30. So we will get here 4.48 gram per liter. So this is the strength of sodium bicarbonate in the solution. So a solution contains sodium carbonate and sodium hydroxide using phenolphthalein as the indicator. 25 ml of the mixture requires, so here in this mixture if you take 25 ml it requires 19.5 ml of 0.04 normality HCl. For the endpoint, first endpoint, if methyl orange is the indicator, then 25 ml of the solution requires 25.9 of the same HCl for endpoint, other endpoint. If you are taking methyl orange, to calculate the concentration of each substance in gram per liter. Again we have to find the strength of the solution. So first we will take the phenolphthalein as indicator. So in this case if you take phenolphthalein, so here again so milli equivalent, because in presence of phenolphthalein this will be fully neutralized, this will be half neutralized. So milli equivalent of NaOH equal to half milli equivalent of Na2CO3. This is nothing but the equal to milli equivalent of HCl. So this is how much? This is given here 19.5 multiplied by 0.005, so which is nothing but the 0.0975. Okay, so from here we can find the it is given here. So now we can use for the methyl orange. So for again, because here we can't get the data properly. Okay, so for sodium hydroxide is 2 is given here, so let us go for the methyl orange. So for methyl orange, so again same, so this half will be neutralized fully into the acid. So again if you use the if you are using methyl orange, so here you are using a phenolphthalein. If you are using only methyl orange, so in this case what will happen? So here milli equivalent of sodium hydroxide, this will be fully neutralized, and plus milli equivalent of Na2CO3 will be neutralized in one step. So here is half of neutralization, so it will be half into 2, that is half into 2, that is full, it will be fully neutralized, and this is equal to how much milli equivalent of HCl used. So milli equivalent HCl is how much used? So that is 25.9 is given here, and 25.9 into concentration is 0.05 normality. So this will be total 0.1295. This is the total milli equivalent. Okay, so this is the one equation 1, this is the one equation 2. Okay, so now we can see that from equation. So if we subtract this minus this, means if you subtract, suppose if you want to subtract what, 2 minus 1, equation 2 minus 1, if you subtract equation, means if you subtract this minus, means what will this will be cancelled. Okay, and this minus this means half of this will becomes half milli equivalent of Na2CO3 will be how much, is 0.1295 minus 0.0975. so if you subtract this minus this, so we will get answer here 0.064. okay, so this is the 0.064, we will get the milli equivalent of sodium carbonate. So we don't need to write half, this will be your milli equivalent of sodium carbonate. Oh no, this will be half only. So this will be your half. Here you can write here 0.032 into 2. okay, so this will become milli equivalent of sodium carbonate is 2 into 0.032, that is 0.064. okay, so here we can find the strength. So here in this case strength will be, you can put here strength here. So a strength of sodium carbonate will be W by 106 by 2 into 1000, so it will be here 0.064. so this is not a strength, this is your weight. This weight is given, so strength will be how much, strength will be your Na2CO3, so this is 25 in 25 ml. So strength of CO3 will be how much, so it will be your 64. So here we will get weight is equal to how much, so on solving 3.392 into 10 power minus 3 gram per 25 ml. so strength will be your 3.392 into 10 power minus 3 and divided by in 25 ml. so here divided by 23 into 1000. okay, so on dividing, here we will get answer 0.1. so here we have 0.1357 gram per liter. Now we can we got the so strength of sodium bicarbonate, and equivalent of sodium bicarbonate is also 0.64. so we can find the milli equivalent of sodium hydroxide, which is nothing but the, if you see the previous equations, that is the milli equivalent of sodium hydroxide, and this by given here now this value 0.1295. so milli equivalent of sodium hydroxide will be 0.1295 minus 0.064. so this will given here 0.0655. so now we can see strength of sodium hydroxide. What will be strength of sodium hydroxide? So here mass of sodium hydroxide will be how much? So if we solve it, so we will get here for mass of sodium hydroxide, means again we have to divide by weight of sodium hydroxide, weight by 40 into 1000 is equal to 0.0655. so here weight will be, weight of sodium hydroxide will be given here 2.62 into 10 power minus 3 gram per 25 ml. so strength will be how much? so strength of sodium hydroxide, that is per liter, will be so 2.62 into 10 power minus 3 and divided by 25 multiplied by 1000. so you will get answer 0.1048 gram per liter. so this is our second answer. so this is the weight of sodium hydroxide, strength of sodium hydroxide, and this is the strength of sodium carbonate in liter. so there are two answers given over here.